Hello everyone, welcome to another lab video. This time we are going to be demonstrating internal and external layer trace cuts. The board we're working with is a prototype from a couple of years ago. It's 6 layers and we're going to be working down in the bottom left here, which has some interesting features, notably signals on outer and inner layers that are fairly close together. So we're going to pretend that there was an error in the design somewhere and one of these wires needs to be cut and potentially rerouted. We'll cover that later. But for the moment, we're focusing on the various techniques for cutting wires. And let's say we're going to go cut the second trace from the top in this big bus. And we're going to do this using a handheld scalpel. There's a couple of different options for blade choices. Personally, I like a number 11 blade, which is this nice pointy tip here. Some guys prefer, I believe it's a number 16, that is a shorter, more squared off tip. I find the 11 is better for getting in tight spaces. I specifically recommend against the use of a hobby knife. These blades have a tendency to be covered in oil and leave residue and also not be as sharp as the surgical grade ones. Go get medical blades, it's worth it. So we're going to take the number 11 scalpel blade and make a small incision on one side of where we want the cut to be, and then again on the other side. It's okay to angle it a little bit. This is actually good. It helps get the removed piece of metal out of the way, and then just kind of go in like that, and there. Get the piece out. Cut a little bit wider. And blow away debris. This is a lot easier if you're working with both eyes and don't have a camera blocking out one of them, but otherwise you guys won't be able to see. Let's make this just a little fatter. Square it off a little bit. There we go. Blow away our residue, and then let's just go get some isopropyl alcohol and clean this up a little bit more. I also find when you get alcohol on the cut, it makes the surface a little bit easier to see what's going on. Notice when the surface is wet, so notice when the surface is wet that you can sort of see through the cut parts of the FR4, and it makes it a little bit easier to see what's going on. So at this point, we've cut the trace. If we want, we can go and recoat the cut area with epoxy to insulate the connections. We'll be doing that in a later video, so I'm not going to do that right now. But now we're going to show a different technique using power tools. So you can use a Dremel or something along those lines for this. I prefer this little rotary tool from Circuit Medic. Fordham and a few other companies make similar tools. And let's select our milling tip. This is, I believe, a 0.3 or 0.4 millimeter mill. That's probably about right for what we're doing. This is also way easier to do when you've got both eyes on the microscope working, but this microscope can't do camera and record at the same time, and both eyes at the same time, so let's do this one down here. Much easier. And then blow away the debris, and we've got our finished cut. One of the advantages of this technique also is that if you notice the bottom of the cut, let's adjust the focus a little bit, the bottom of the cut is nice and smooth. We don't have any of the shredded glass fibers. The cut using the scalpel is more likely to damage the board substrate. You can get things soaking into the PCB and causing long-term reliability problems. So if you are cutting with a scalpel and you're going to use the board for a while, it is more important to recoat with epoxy. Not that it's a bad idea to do it if you've used a rotary tool, but it is a little less critical. So now let's do something a little more interesting. Let's go find a trace on an inner layer to cut. So just a little bit above this bus, we've got those two vias to our top right. Center this a little bit. So those vias are where an internal bus changes from layers 2 to 3, and just to the left of them, I think, is probably going to be a good spot to cut one of them. So since this is an introductory video, we're not going to do anything too super exciting. We're not going to be dodging around upper layer traces. So we're just going to be working with, let's take a larger mill to expose the air. That should probably be about good. So we're going to start by just milling out a large area just to the left of these vias and try to get an idea of what we're actually looking at, because there are going to be registration errors in the PCB. It's not going to look exactly like the Gerber does. So it's always wise to get the lay of the land a little bit before you start. Alright, so we're down to the ground plane. The signals are on the other side of the ground plane, which I did have turned off in the KiCad view. So let's go expose a little bit more of this ground plane before we start cutting through it. Maybe turn the RPM down. We don't want to take away too much material too fast. Alright, that looks like a big enough space to work in. So now that we've cleared out the space, let's switch back to our smaller mill, since we just want to cut one of these traces. Blow away our cutting debris again. Let's get exposure a little bit. And let's get a little alcohol on here, clean away any more dust. The other benefit of using alcohol, as I mentioned earlier, is it does do a pretty good job of letting you see through the FR4. So yeah, we can definitely see there are two traces there. Let's actually put a drop on there just for the camera's sake. There we go. So now we've got a drop of alcohol on the board. You can see right through the FR4. This is the pre-preg between the ground plane on layer 2 and the traces on layer 3. So if we go get a swab, get this out of the way so it's not going to block us working. Alright, that looks good. So now at this point, if we wanted to, we could use the scalpel method. I'm going to use the rotary tool since I've already got it set up. I'm just going to zoom in a little bit more so I can do the precision cut here. And I've actually got a nick in the FR4 there, or the solder mask. Sorry. There's a little chunk of chipped solder mask, but I won't deal with that later. Alright, so now we're just going to try and cut the upper one of those traces. Focus a little bit. Mill down a little more. Okay, so at this point we've got the trace fully exposed. So if we were going to go do an edit on the inner layer and actually solder something to there, maybe add a passive or something, this would probably be a good time to do that. Otherwise, let's continue cutting through. And we've now fully broken the trace. And let's go swab off a little more of the debris. And there we go, there's our completed edit. And finally, I do not recommend doing this, but I am going to try just for kicks doing the same circuit cut just a little bit off to the left using the scalpel method, and you'll see why I never actually use this method. It is much more difficult, especially when you have to go through a ground plane. If you absolutely must do interlayer rework and you don't have a rotary tool, you can get somewhat acceptable results this way. It should be a last resort. So notice I've already used enough pressure, I've bent the tip of the scalpel. Trying to do deep cuts this way is not good for the blades. You're going to probably want a few spares handy. Using pretty significant pressure here, trying to even get down through the top FR4. Alright, there's some solder mask, and again you can see we're damaging the weave. We've got a bunch of glass fibers all over the place. This is not good. Blow some of this debris out so you can see how deep we are. Okay, cut a few of those fibers. Wider, we're going to have to go down probably 200-300 microns, I believe. I forget what the stack up on this board is. It's a prototype from a couple of years ago that never went anywhere. The client went out of business, so that was that. Alright, I see some copper, so we're just starting to hit the ground plane. You can see how slow this is. Again, not recommended. Blade slip there. This is one of the problems if you use this much pressure. You can have the blade slip and damage something you care about. In this case, we just scraped the solder mask, so it's no biggie, but one of the reasons why anything requiring a lot of force is risky in rework. You always want to use the minimum force possible, and cutting through 100 microns of pre-preg is not something you do with light force, so So I think we're through most of the ground plane here. There's still a bit of residue there. I don't think this hole is even large enough to work with either. I also lost the tip of my blade, so I'm going to go and put a new blade on. Remember what I said about cutting through FR4 being murder on blades. Later. Okay, back to where we left off. Nice new blade that I'm about to row in. So we've exposed the ground plane. Let's clear some more of this junk out. And let's see if there's any way we can cut through this. Feels like we got somewhere. And we broke the blade again. Good thing I have a whole box of these. So we were somewhere up on the top side, I believe. And if we're lucky, we can kind of peel off this blade again. Alright, that's whatever, that's good enough. Alright, so we broke this blade too. First time I used it, but we got a hole in the ground plane. Let's go get another drop of alcohol in there, show you guys what's still in there. Okay, so we've got the trace. We got to maybe cut a little bit more square off the edges of the hole, but we're in the right place, so that's good. Let's go make that hole just a little bit wider. Cut some more of that one. Is that more ground plane, or is that actually our trace down there at the bottom? Okay, it looks like we're hitting the trace, so that's progress. Alright, now we just gotta cut through it. My hand bumped the microscope. Okay, so we did finally cut through it. The cut is not nearly as clean as before. We could obviously straighten it up if we wanted to. Let's just go do that. Get some of those copper particles out of the hole. So a few last pieces out. And let's put that down and see how we did. Well, we did break the trace. It took way longer, burned through, I believe, 4 scalpel blades, and much less clean, usable result. Certainly, I would not want to try opening up an area big enough to solder to on a situation like this. It can be done as a last resort. I do not ever, again, recommend using a handheld scalpel for inner layer rework. For outer layer, it'll work fine. If you've got the rotary tool, use it for everything. It's pretty much always the better choice. And that's all for today. Thank you for watching, and we'll see you next time.